Okay, update's done. Well, that was interesting. Let's see if we can hold a stream now. So this is the ECS for the GUI. I don't know why I did this. Entity component system for the graphical user interface. I'm going to try and do it. I really am. Honest. Get rid of that battery. Oh god. Have I run out of coffee now? I think I have. Alrighty. Let's go to the live screen. And let's pop you to full. Let's see if we can do anything on here. Hey, take 3 indeed. Yeah. Technical issues this morning? Yeah, a couple. Right, so those are arrays. Okay, all I've done so far this morning on take 1 and 2 is add files, as you can see up top. Nothing major. So I've added game objects. There you go. Game objects.swift. We've added user input.swift. And we got the bell saying we're online. Oh good. Thank God for that. Oh, it's working now. Oh, that's interesting. It's working properly now. This is fine. I'm getting the right numbers. So we're doing good, I think. What I'm trying to do is work out what to do with this variable, because this isn't a let, it's a var of int 32s. So we're trying to start up an ECS. And what I would like to enter into this ECS are position and object. So we called them last time position and model. We were just titling them like this, were we? Okay, I think we can do better. It's the naming conventions that I need to get around. So, well, at least we got further than we did last time. It hasn't broken down on me totally. What I want to do is something like a struct. Call it a component. No, don't call it a component. Call it model underscore position. Yeah. Now this is going to get very, very interesting very, very quickly. So the first thing we put in one of these is the object ID always. Var object ID. That's a given. That is a total given. We have to do that. Oh, it's come to int 32. All right, well, let's go with int 32s then, all the way around. Let's start designing this properly. We won't need more than that, I don't think. In fact, I don't think we'll need more than int 16. So we're going to have a model position. And the other thing I want to add, our mouse is working good, is a struct. And it's going to be GUI, and it's going to be element. So we're going to do a 3D, 4D, 3D graphical user interface. And the first thing we have to put in is, of course, object ID. Now, we'll fill these in a minute or two, but let's go int 32. Okay. Everything's going to match up there. That's brilliant. Now, what do we need to know for a model? We need to know these three things. So that's easy. So we want those three. So that's our vertex buffer, index buffer, and indices count. For position, okay, we need these here, which is a vec3 position. I'm just wondering whether I should carry the model matrix with it. We do here, so let's do it here. Alright, I'm happier now with that. Is that going to really wreck things up? It's a float 4x4. No, it's not going to wreck things up at this point. So that's fine. Now I'm going to need my position stuff, aren't I? So variable position. And that is going to be a float 3. Or is it? It's not. No. We can do better than that. Let me just put it all in, and then we can do better than this, definitely. Var, what have we got? Rotation X. X colon, that was a float. No, with a capital F, please. Float. No. A float. Leave me alone. Can that be a 32? Did that say? Wow, I didn't know that. There we go, I'm learning already. We'll do a rotation X, Y, and Z. Rotation X, Y. We'll do the same again. There we go. And the last one there is a var rotation Z. So we know what we need, so it's going to be a lot easier to do it this time. And I'm also getting better responses out of Swift, I think, today. Like, no errors. That won't last. And scale. And that's going to be a float 32. Now we can initialize this, couldn't we? No, better not. Right, that position. It's bothering me. Why is it bothering me? Because on the vertex buffer, it's going to be different. How do we do it on our vertex buffer here for sand floor? We use SimD3s. Ignore. We'll solve any problems. Well, it's not going to solve. It's not going to be a problem with this because this is just data. That's fine. Okay, do we need any enumerations for this lot? Not really. I'm trying to think. Let's have a look at the enumerations on this side. We had attack target health status. Game component. Ah. Yes, we do want that. We want our component enumeration, don't we? How do we do an enumeration? Use the right mouse is how we do it. Trying to think, where did I use an enumeration? Sandbox, we did one. I did it on purpose so that I could see what the damn thing looked like. So it's enum, the name, and curly brackets. That's not too difficult. I hope. Enum. What we're going to call it, just components. I want to keep it standard. Game component. Okay. And then it's a bracket. And then we just start our enum, don't we? And we were using comp underscore. In this case, we're just going to have model element and GUI element. No. Model position. Model position. We've rolled into 1. That's equals 0. Stored properties, okay. Comp GUI element, which I haven't defined yet. Do you want a comma or something? Weird. Weird. Open brackets, close brackets. Alright. That looks like a variable to me. Keep you open a second. So, what are you asking for here? Expected in body of function declaration. Insert func. I want enums, not bloody functions. No. La 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 la. Search documentation. Enum. Enumeration cases. This doesn't make sense. Alright, that's fine. How come I don't know? That looks weird. That looks very weird to me. Oh, enum's not going to work. Okay. Swift. How to define an enum. Right, you put case in front of it. Okay, why didn't you just say that? What's all this rubbish here then? I honestly don't understand the IntelliSense, to be quite honest with you. The IntelliSense on this kind of thing is, ooh, it needs updating a little, I think. So yeah, right, we can do that. That's great. So case that equals 0. Can I put that in? No. Alright, fair enough. Whatever. Oh dear. I'm struggling a little bit today. I do apologise. I have not been very well, to say the least. Right, so we now have what I would call an ECS system. That's it. That's how you make one. You don't do fancy inheritance or anything else. It's just a couple of structs and an enum. That's ECS. It's not very hard. Right, so in objects, game objects, what I want to do is something in parallel to game objects. Instead of saying game objects, we're going to have GUI objects. objects. I think that's a good way of doing it. Yeah, because this will be a good test. Muppet, are you alright? Yeah, that's furballing and coughing at the same time. Wow, this cat's amazing. You finished yet? Nope. Lovely. So yeah, he's okay. He's okay. Just checked. Oh God. What will I need? Now I could reproduce that, but there's no point, so I can just use model position. I want to hold some text. I'm just going to put in name for now because I don't know what to put actually. Something like that. Could just call it text, couldn't we? Yeah, it's going to allow us to do that. For now, I'm not sure. Alright, okay, we were thinking about this and we thought a GUI objects would be good. Come on, love. Oh, bless, he's come for a cuddle. Oh, bless, love. We had a good cough there. Let's just rub that throat a little bit. Oh, bless you. Oh well. He's not very well. What I'm hoping to do is mirror the ideas that we had in in our game objects. Right. I'm happy with what I've done so far out of that. I don't think I need anything else. Oh, yes, we do. Right down at the bottom. Game state. Yeah, this needed tidying up as well. This should really only hold bools. So we're going to make a new rule for game state, that it can only hold bools. Let's do that. Which means we can build it better, I think. Are you alright there, Muppet? You going to be okay? Yeah? Alright, we'll keep you cuddled and warm. Struct game state. So let's put a rule on this one. Bool. Running. Game is running. I think that's the only thing I want on there, and it's... I'm doing it the wrong way around, aren't I? So that's a var. And that's a bool. Lovely. I think that's the only thing I want in there at the moment. Yeah. Right. Good. I think that might work. We can change this at any time we want, so that's good. Yeah, okay. I don't think there's anything else I need. Okay. Yeah, all of this is going to change. That's a shame. What I think I'll do is I'll rewrite the combat system on a different machine somewhere and then just import it. I could do. Do we have sandmaths at this point? Yes, we do. Fantastic. Okay. Build succeeded. We're fine. We're source controlled. Lovely. Right. I'm going to call that the beginning. The beginning of our ECS for the GUI. Great. I love that. That's brilliant. Lovely. What we need to do now is construct an element from all of that. Let's have a look, see. What have you got here now? Alright, fine. We want to look at what we did in here. This was our central point. This was the beating heart of our last system. Well, it isn't going to be now. Open with, yeah. Just text edit will do fine. Lovely. So as we can see, we had all of these static items in global space. Was it? Yeah. 4 different data sets. Now if I make this into a class, it's going to mess everything up completely, isn't it? This is going to be interesting. Let's just think about it a second. So what we are using here how shall we store all of this information? I think it should still be in global. I think it should go in common. I think we should move all of our ECS component stuff to common. All of this static game object stuff. But that static was to keep it in this file. Oh, right. It says import foundation, so we will. I wonder if it'll stay the same. So if I put static in, oh, we do have it. How does that work? No idea. Because this will be UI objects. Separate to game objects. No, not really. Let's try it. So, instead of game objects, I'm going to have GUI. And that's going to be a constant. Okay. It's going to be a let. And our objects are just going to be integers. Global let declaration requires an initializer expression. Replace static with something, fix. An initializer expression, so it wants to equal something, does it? interesting. I do want it static though, unless it can't be. And if that's the case, it may as well go in common. Lovely. Thank you. Thank you, Muppet. Right. Alright, let's have a look what we can do then. Swift. How to make or make a global array. Is there anything here? Oh god. How to create global array version. Let's have a look at this one. Okay. So variable name colon, and then it equals something. Right, so they are making it equal to something. That really doesn't help much. Class, let var pi, yeah, right, okay. You're not helping. Your advertising, not really helping. Oh god. So yeah, that was really helpful. Oh god. I know that's the basics of it. This constant declaration. But when it comes to arrays, I need something better. Alias, fantastic. Functions. Yeah, this is great. On this page. Okay. I'm not really getting much help from this, am I? No. Whatever. Alright, it's just equal brackets. Initialize with 0 values. Okay. Array directly without specifying a data type, but must initialize with some values so that the compiler can infer its type. Alright. So I can put an array repeating 0 count. Okay. The values are stored. Great. You haven't mentioned vectors. Okay. Interesting. Alright. This brings up a problem. Thank you, Muppet. Right, ignore problem. Still want it static though. Yeah? Static properties may only be declared on a type. Fair enough. Ignore for now until I know more. And that's the way you have to do it, unfortunately, when you're researching a new language. Just ignore a lot of it. So I want my common. And we want game components, game entities, Right, so that should be game components type. I'm actually wondering whether I should just put it in here and say sod off. Okay, so game entities. Copy. That's our first one. Common, please. Thank you. There we go. Alright, so it isn't an int32. I want game entities in there. Like that. Yep. Ah, it's here. So we just called that object, didn't we? Lowercase, please. Let GUI object and then we want the different components. Right, got you. Ending in the word component. Right. Next one up is model position. Model position component. Yeah. And that's going to be of type model position. Good. Next one is an element. So we only need those three. I think we might be better initializing our structs, but we can't. No. Don't do it. Okay. GUI element component. We're going to fill you up with something in a minute. Alright, okay. And that's going to be GUI element. That's you done. It's some of those two I want to mess around with. Alright. Let's have a look now. What do we do with all this rubbish? We initialize it. We have an object initializer. So we could have a GUI initialize. Well, we do have to load up all the bits and pieces, don't we? So what we're looking at there would be a func GUI underscore initialize that sounds roughly about what I was doing. Alrighty. So in here we were initializing all of these lot. That's good. Now for each component, what information do we need? Good point. We would need to load models. So, load GUI models. What else do we want to do? Set the positions, maybe. Set initial layout, maybe. What else can we do? And at that point, we should have our game objects. The GUI objects, sorry. At this point, we should have the data to set the GUI object. I'm not sure about it. I think we have to do all three at once, so... Okay. We are going to need something in the future. No, it doesn't do it automatically on here, does it? You have to do that. In OpenGL, load model 3D. So that would go in here. And that would be load model underscore 3D. We'll create that file as well. All right. So we're going to use load model 3D for that. Interesting. Meow meow. Alright. Shaders we've got, yeah. What else will we need? We'll need models. Okay, so here Stop it, pudding. Do you mean to say it's coffee time already? How did I spell it? Source. There we go. And in resource, we had shaders. Let's have a look at that. I called it GLSL. Okay, that's what I'll call it then. I don't care. G. Oh, it's over there still. So we'll have exactly the same structure, even though GLSL doesn't exist on this. Where's my shaders? In source. Okay. New group. Models, plural. That's better. That's the right way up. Metal Sun GMNOPQRS. Yep, that's the right way up. Just have a look at that, didn't I? Oh wow. Definitely want to have a look at that sometime. And I think we're there. I think we're actually at a cup of coffee. We now have a base ECS system. Well, a bit of one. So that's what we are looking at now. Excellent. I'm liking this. This is so much easier than the first time round. Having information to go off and being able to set things up properly is a lot better. In this one, in what I haven't said so far, in part 2, this is 1. This is all in C. I usually write any initial like code, I will write in the simplest language I've got available. In this case it was C, so that's what we use. It's the simplest language to write anything in. Swift is fighting me a little bit, but not as much now, so that's good. We had an initializer. What else have we got in here? Wow, that's an initializer that needs to be sorted out. So what we would need is add model position and add GUI element, I think. Right, object update, of course, yeah. So you got your initializer. You would have a function for well, actually, I'm going to start them all with GUI, aren't I? GUI update. That can do something. Haven't decided yet. What else can we have? So we want to register. This is where I want a vector. I wonder if Swift has vectors. Vector containers. Swift vector array, I suppose. Here we go. Where's working with vectors? Use vectors to calculate geometric values. No, you prat. The other kind of vectors. Oh dear. Blah de blah de blah vector, yeah. NS array, yeah. NS array UI image. That's illegal? Okay. Right. We'll find out, won't we? So we were just calling these anything we wanted to at the time. I don't want the star though. I do want the star in the other one. Wonder if that's going to work. I wonder if that will work, actually. An NS array of pointers for components. So that would be an NS array of components. Is that legal? Interesting. It doesn't like the star. Oh, wait a minute. Does the star have to actually touch or something? Oh, it goes out to a star again. Interesting. No, it doesn't like that. What's this expected thing on about? I'm missing something. So it would just be blah star whatever. Okay. Don't like this. I mean, really? All right. There you go. Array types are now written with brackets around the element type. All right. You'd have to define components, yeah. I've got you. Never mind. See, that's what it leads me to. It's just totally undefined. Not sure exactly what that does. That's a problem. Okay. Oh, God. Vector math. Yay! Swift library for the Mac. Yippee! No thanks. I'll write me own. Yeah, right, okay. Not overly helpful in here. Are we getting anywhere? Program also to work when we have 3 grades. Okay. Declaring arrays. Am I going to have to create vectors myself? Empty array events. It's not ints that I want, it's the memory addresses I want. Some odd, yeah, reverse sorting. Search. Funny. You haven't told me anything here. So it said vectors, but it comes back as arrays. No real mention of vectors here. Alright, not a problem. I'll continue with what I'm doing then. I don't think I'm going to get much help from the community, because I don't think the community actually likes to break through the box. I like to break the boundaries and find out what can and can't be done. That looks interesting, because each component will be its own array. I'm going to go with that. Because each of these is its own array, and each one of these needs to go into there. So we will need to add, we'll need a way of doing that, because that's going to be very, very interesting. GUI add model position. So I've got no idea how to do that. That's great. Fine. I prefer it when I've got no idea how to do things. Again, we're going to duplicate because I don't know what we're going to end up with. Add element. There we go. So those are the things that I want so far. So we can initialize them, we'll be able to update them, and we'll be able to add that to that. We also need to be able to add game objects into a vector. For layout, I'm going to call it layout, I think. GUI layout. So let GUI layout be a bunch of NS arrays. NS array, and we don't know what's in there yet. Okay, that's what I'm going to try and do. And now we get a cup of coffee for our brilliance. So, no, my coffee cup's empty. One sec. I'm going to do this the other way around this time. So yeah, that's my thoughts. If anybody knows any better than this, or has experimented in swift and found ways of doing this kind of thing, let me know. And of course, if you're looking at this on YouTube, drop a comment. I could be going about this completely the wrong way. But I don't want classes, and I do not want inheritance at all. I want a program that I know what it's doing rather than a program that's being controlled by the machine. So what we've got here looks a lot cleaner than what's on the right hand side anyway. So all that stuff on the right hand side is going to be cleaned up into just stats. I'm just going to have game stats, I think, for the object, or game object stats, or whatever. Entity stats. We'll think about it. Because we can reuse the model position out of this one. That will be good. One of the things I don't understand is why metal can only be used on a Mac. Introverted apple. Right, let's go do it. Let's get some photos of me up on the screen and coffee time. Yeah, I was hearing you meow. Don't worry, come and get some food. Come on, Mum. Alrighty. This is a part of programming that I love because it may look as though I don't know what I'm doing, but research is about emptying your head and not assuming anything. I want to have a look at this input, don't I? Matrix for shaders. Matrix for shaders. Model loading. I want to have an initial attempt at model loading. Alright, let's have a look at that. What have we got? Nothing. What do we want? I don't know. Right, so I'm gonna this is gonna take time to research, but I don't care. Model loading. Ah, yes, I know how I want to do this. Metal Sandbox archive. Right, okay, blah blah blah. No, not in there. What have we got in here? Ah, right. Nope, not in that. How do I get rid of that? Thank you. Yeah. Look in here. Let's see how we did it here. OpenGL. Text edit. Thank you. Right, so I know how I want to set this up already. That tells me how to do it. So it's just load a model 3D is going to be the name of this. Func load model 3D, keeping the same names as usual. And then we want to quickly look at sand floor. Actually, I'll just copy that bit out. I want that to be the same. Like that. Yeah, I do. Okay. So we want to do the same kind of thing that we've done in here. Actually, I'm just going to copy it. Loading a model should be similar, if not equal to, but I doubt it. I don't think they've been that good at this. Use of undeclared type. Right, okay. Alright, so is that all we did in here? Did we do anything special? We took in a colour, did we? Yeah, colour. Alright. So we're going to have to think differently about colour. Maybe. This is going to be interesting. I wonder what it's going to do. Or whether I'm going to need to use a texture. Let's find out what it's going to do first. May need to set our own colour. We may actually need to break out of this using only one buffer system. That's also what I'm thinking. Okay. I'm just thinking, I'm not doing. Come on. That's what I do a lot of for my research. I do a lot of thinking. So come back to me here. So it's going to be Swift. Mac IO model. No, it's going to be metal. Mac metal IO model. Did that well. Model IO. Documentation. Swift. Right, okay, we've got something. That's good. What I'm going to do is I'm just going to window this out. Okay. Lovely. It's reading time. Use vertex data to specify the area within source pixel data. What? That a render command will draw. Okay. MTK metal vertex format from model IO. MTK model IO vertex format from metal. Oh yes, input output, yeah. So we're going to need that function. We could have a look at that. Converting between model IO metal vertex descriptors. Alright. What are we actually going to need at the bottom? We want a vertex buffer, an index buffer, and an indices count. It sounds like this one here. Okay. Is that what you're going to tell us? Oh dear. On this page, topics. Oh, here we go. All right. Metal specific interface. Ah, this is better. Metal kits highly optimized functions and objects allow for efficient data transfer between model I/O meshes and metal buffers. We are going to need an MTK mesh, a container for the vertex data of. All right. See also rendering. Yeah, fine. We've got rendering. How do we actually get it? Is it coming in from here? Loading meshes from assets. We need an asset. A device. And it returns a model I/O mesh. Shiz. Alright, let's have a look at this. Oh, throws. Alright, just open a new page. Mac metal loading load 3D model example. Let's see if we can find an example of this. Importing and exporting 3D assets. You create an MDL asset object by loading data from a URL, a universal resource library. So how do we get a URL? I think we're already on this page. Okay. Okay, that's for... Ooh, bounding boxes. Yum yum. Creating an asset. Dee. Returns a Boolean value that indicates whether the MDL asset class can read asset data from files with the specified extension. I think we're going to need an asset. We need a test asset. What shall we use? A model. Okay, let's break out of this again. I think we've found what we're after. Excellent. Let's go and find an asset. Where's this gone now? Xcode. Oh, you're over here, are you? Right, okay. Strange person. We need an asset. What shall we have? Archive. You'll have assets. Monster object. New file, delete, new group, source control. Oh, it doesn't say add. So I guess it's been added. It's already been added. So that's done. We have a monster obj. Lovely. What file am I in? Alright. Fair enough. Alright, we can get rid of some of this, I think, soon. So, what exactly are you going to be asking us to do here? So, where do I get this from? Okay. So it just says do it. Alright, so let's have a look. can import if not we haven't set up a game model. Not to worry. If not, I don't really want to test for this. I don't know why I want to test for it. I know it can do that file extension, so... Alright. Init a URL. Okay. It's a struct. Relative to its directory, file URL with path. File URL with file system representation. Resolving a bookmark, thank you. Encoding and decoding a URL. Parts of a URL. Oh right, we can find the host and stuff on this. This is going to be interesting later on. Unsafe. Ah dear. I just think we set it to a path. Right, so I need a URL, so file. Alright, so a variable called file is going to be a URL, I suppose. URL, yeah. Alright, so file dot, here we go, all the different options now. Got bool data, URL, yeah, okay. Void, deleting, strings, description, great. Encoding. Oh no, that's a bool. Looking for the strings. Ah, path. There's a path. Oops, it's just disappeared on me. Alright, let's go the other way. Alright. Quite a few voids. Don't want to do resource values. Resolving, remove relative path. I think we should use that one. We've got a couple of strings here. Could be hash file. Can I just go straight in with a string or not? BSM internal notify key. Okay. Can I call? What I'm thinking of doing is just doing that. Of non-function type string. Is it equals then? Is it as stupid as that? It's a getter, not a setter. Right, well, thank you for telling me that in the end. That's very nice of you. So it's not relative path. That's a getter, not a setter. Ah, God help us all. Path equals get only property. Is it init? File dot init. No. How the hell do you use this? by calling function init contents of encoding. Okay. You can construct URLs and access their parts for URLs that represent coding, working, accessing. I don't want to access, I want to set it up. Symlinks standardize. Okay. Adding path components. Append. Sounds alright. There's append and appending. Right. Okay, let's try that. So file dot append looks good. And then we want a string. Do that. Oh, right, it's not complaining at me now. Oh, this is... Pass by reference before being initialized. Okay. We have to initialize it, okay. File equals URL, open brackets, and it's going to be that. Let's try wait a minute, there's different ways you can do this. File reference literal resource name. Interesting. Right, we can query it with a string. String relative to a different URL. Right. I think it's that one. File reference literal resource name. How do I search for this? It doesn't come up here. System represent. Well, here we go. Reference literal resource name. That's the one I want to look at. Creates a URL from a playground file literal. So, no, is the answer to that. File URL with path. We'll do that one. Creates a file URL that references a local file or directory at path. Does that include the file? We'll go with it. I pressed tab and it came up with that. Don't understand. I want to do that one there, please. Thank you. And the string will be resource. Models. And monster.obj. Was written to but never read. Fair enough. That I don't mind. Why has the F been left off? For God's sake. Right, so I think I've got a URL. Okay. Now how do we load it? A container, an object, base class for objects that are part of a 3D asset, including meshes, cameras and lights. I don't really want a class. Alright, so we did the URL thing. Well, initialize an empty asset using the specified buffer allocator. Vertex descriptor and buffer allocator. We don't have a vertex descriptor. Have we already got a mesh buffer allocator? Hey, rendering. Do we already have this stuff or not? Well, I've got a vertex descriptor. It's here. How did we get our buffer allocator? I bet that's in Sandfloor, isn't it? Make buffer. So that's coming off device. Let's see if we're allowed to make one. What should we call it? Preserve topology. What? Buffer allocator. Yeah. Let's try a buffer allocator. Do we need to send through our vertex descriptor? This is the bigger question. I think we do. We've got a URL. We need a vertex descriptor. MDL vertex descriptor. I think we've got that in rendering. Oh, we haven't. We've got an MTL. Okay. Interesting. All right. Let's go with it. All right, so we've got our URL. Let's get an MDL vertex descriptor. So let vertex descriptor equal something. Yeah, okay. And it says MDL. MDL. Vertex descriptor. There it is. We've got one. Alrighty. What else do we need? A buffer allocator. Okay. How have we done buffer allocation in the past? We've used device. This is just saying use an MDL mesh buffer allocator. I don't think that's coming off the device. So let buffer allocator, is it? Yep. Buffer allocator. Oops. Equal an MDL. Buffer. Yeah, we have one. No, mesh buffer allocator. That'll do me. That one. Alrighty. So URL buffer allocator, and we've got an empty vertex descriptor as well. Initializes an asset from the file at the specified URL. I'm not sure I've got my URL right. Oh, what's wrong with you? You one of these silly things. Cannot be constructed because it has no accessible initializers. But according to this, you... MDL mesh buffer allocator, it's got a question mark at the end. Question mark? No. I think you're a pling, mate. I think you're one of them. No, you're not. So... how do we get a buffer allocator? No accessible initializer. Is it a device? No. So how do you make one then? That's a bit dumb. Did you mean to use equals question mark? No. Alright. I don't know. Right. Buffer allocator. You're going to have to tell me how to do it, mate. Because otherwise, we can't get through this. Use this initializer. It tells me here you haven't got one, mate. And it just goes through this creating an asset thing again. An MTL device. Yeah, I've got one of those. Alright, let's try this a different way around then. That's not going to work. It doesn't tell me if it's a var or not. Okay. I'll try it here, who cares? MTK mesh. Oops. Mesh buffer allocator. Okay. Alright. So I think we've got somewhere. That doesn't belong here though. Pop you up here for a minute. So I think it's a var, it's gonna have to be. Alright, what's wrong with you now? Just never used? Variable buffer allocator was never used. Consider replace. Yeah, right, okay. Thanks. Alrighty. Alright, I'm also going to put you up there as well. Okay. Let's see what we can do with this buffer. Do I need to initialize this buffer, please? Doesn't say so, does it? Buffer allocator. The allocator object to use for loading or creating mesh data associated with an asset, or nil to use a default allocator. Fine. So we can change the allocator. Currently it's default. What does this give us? Init what? Doesn't give us anything back. It just says initializes that. Who's calling this? Obviously it must be the allocator. By the looks of it. So, buffer allocator. Doesn't exactly make sense to me. Let's go back another page. Okay. Creating an asset. We've got that. Who does this? Who does this init? I think we do. A new asset return value, you see? A new asset object. Where do we place that? False for the preserve topology parameter in ignoring errors. This documentation needs some getting used to. I don't know who's doing it. I'm thinking we might need some kind of mesh. But it's not telling us that. The base class for objects. That part, yeah, okay. Transform. Oh, right, we have an MDL. Transform. Didn't know that. A mesh. That's when you're working with it, isn't it? Because we have to pull that out. So that will be like a mesh kind of thing. All right. Mesh contains one or more submesh objects. Yeah, each submesh contains index buffer. Yeah. Creating a custom mesh, blah, blah. And it comes back to this init shit. Oh. Wow. Right, so we need a mesh buffer. We haven't got past the allocator yet, so we don't... Maybe that's what it is. Ooh. Have we got a vertex buffer? MDL vertex descriptor. A buffer. We don't have a mesh buffer. Is this the missing link? Creates a mesh from a single vertex buffer. With the specified parameters. That might be going the wrong way round. Does it actually give us any examples in here? Because I'm getting a bit fed up with this. No. I'd like to know what init means. I know what initialization of something is, but it doesn't tell me what I actually need to initialize it from. Well, I find that amazing. No, I just want to load a model. What the hell has that got to do with what I've just asked? Hope it's better than the last bloody advert. Okay, so what are you going to tell us about Model I/O? Oh, you're going to send us here. You are fantastic. Okay. Adding depth to the pipeline state. Yes, please. All right. We'll come back to you. Rendering with depth. Lighting and materials. Where's the loading of the goddamn model? Previous article. Getting started. Yay! Alright, so I've done all that. I haven't done subviews. No idea what that's talking. I might read this actually. Okay, render class, yeah, we've done that. Draw, yeah. View delegate, we've done that. Draw in, MTK view, yeah. Setting up as the views delegate, we've done that. Yeah. Ah, here we go. Import model IO. All right. So we do need the device. I was right about that. Load resources. All right. Oh, right, okay. Let's try their version. My version was rubbish. Going to this. So, it starts off with let model underscore URL equal bundle. Right, we do have that. Main. We do have that. URL. We do have that. For resource with extension. That one. For resource string. Dink. Monster. With extension obj. OBJ. Ah, now you're not crying at me. We'll get rid of that one now because we've just replaced it. Fantastic, we're getting somewhere. Right, the vertex descriptor. Right, so I did get that bit right. So let vertex I'll do it properly this time. Descriptor. Have I got any coffee left? No. Equal MDL vertex descriptor. Blah blah. Lovely. All right. Right, you're taking in position, normal, and textures. I just want position. Okay. So vertex descriptor dot attributes 0. Got a feeling these have to match. Equals. Press return now, I think. MDL. Actually, no. We'll let it sort itself out. MDL vertex attribute. Vertex attribute. You. Come here. Open brackets. Return. Return. Oh no, that was right. Return, go in. Name. And that's going to be MDL vertex attribute position. position, thank you. We are going to give it a format. Colon. That's going to be a .float3. That's obvious. We're going to give it an offset of 0. That I am sure of. And buffer index 0. Alright, at this point, I would like to check that against what I've already done. Right. It's not held in there. Okay. But we do have a vertex descriptor now. Offset buffer index. So it's this bit we're doing. And this is going to have to be added to... Yeah, okay, right, fine. Carry on. Don't want any view texture coordinates and all that stuff, and I certainly don't want the normals at this point, but we will need them. Stuff it, I'm going to take them. Now if I put normals on it, it'll be... What I'll do then... It's just that we're going to have to swap everything around because of it. I can add it in and not use it. There is that. Right, what I also could do... How do you do things in this thing? That's given me over there. So if I click in here, aha. Add bookmark. Add. Right, so I can get back here. Alright, so yeah, I'll just skip that for a second. We'll need to use a vertex descriptor later on, so add a property for it to the renderer class. We already have. But it's changing it. It's alright, because we're going to be leaving ours in here. Okay. It's just that they change it here. That's interesting. Right, okay. So it is a var. I can't use self. Right, so that's fine. Buffer allocators. Okay, let's have a buffer allocator. So let buffer. So I did get quite far along on this one. Allocator equals. We know how to do this one. Oh, it wanted a device. Yeah, of course. We all knew that from the bloody thing that gave us. Mesh buffer allocator. Ah, doesn't even put the brackets in. And that's device. Device. We've got that. Alright. This is where we got stuck. Because it wouldn't tell us who was doing what. And it was the MDL asset doing this. You basket cases. Why don't you damn well tell us? Which comes after the vertex descriptor. Apple's manual is off its head. Absolutely off its head. How these people have worked out that that goes with this, I don't know. URL model URL. Oh, this has got a lot of commas in it, hasn't it? Dee-be-dee-be-dum-dum. Bink. Ah, drinks. Seppi. What do I think of what? Gyra? I don't think of Gyra. Never heard of it. I probably have, actually. Yes, I have heard of it. And no, I really don't think about stuff I don't use. Let's have a quick look, though, whilst I'm here. Gyra. Wiki Gyra. Da-ba-da-ba-da. Oh, project management tool. Blood and sand. What do you need one of them for? This rubbish. Oh, that stuff. No. Sorry, if people don't know what the bloody hell they're doing and they need that to remind them, don't employ them. There you go. That's what I think about it. Love it when a plan comes together. If a business needs something like that, it's in trouble. Seriously. Yeah, I know. I understand all what these project management things do and all the rest of it. Well, there's an easy way to manage a project. You go to each one of your programs and say, this is what you are going to program, and then you walk away and let them do it. Without giving them deadlines, without giving them all of that rubbish. And if they can't program it, you get a different programmer. If they turn around and say, oh, I want a specification, you turn around and say, well, don't you know how to do this? Then you'd better start researching, hadn't you? And that programmer should be able to program within 7 days code or prototype code that should work. I know I can. Actually, yeah, I can. And I'm not a programmer. You look at what they've done, and Then you thrash out, you might have an ideas session. You thrash out some ideas and do prototyping. And you prototype some ideas, see if they'll work with what he's done. And if you think the project at that point needs splitting up, you get another programmer. Etc, etc, etc. And it's a rolling machine where one programmer does one thing. And they are responsible for that one thing. You can split that one thing into different parts and assign it to different programmers because it's getting larger than the initial program, but you cannot start swapping things around and saying, here's your deadlines. Your deadline is finish the program. You don't need a ticket system now. Everybody who is programming should be programming a program from start to finish on a certain subject. At the end of the day, all of those programmers have to get together and join those programs together. That's why you need prototype code. Because once the programmers have got past the stage of prototyping, you can then take a copy of all of those prototypes and join them together. Somebody else can do that in the meantime. And then, when it comes to the stage of actually making the final program with all its bits and pieces, it's like I'm doing the user interface. I haven't put in all the rest of the stuff, but I'm still programming the user interface. Obviously, it's being done in a stupid fashion, but that's Swift for you. But no, you don't need all of that rubbish. As long as people know what they're doing when they get up in the morning and they're having the breakfast, they'll be more productive. If people have to walk into the office without knowing what they're doing and look at a bloody board to say, oh, you're doing this today. No, doesn't work. If I don't know what I'm going to do when I get up in the morning, I'd stay in bed. And that's how a lot of people think about their jobs. I think I prefer to stay in bed this morning. I want a duvet day. And that's why people are not productive. Because they don't enjoy what they're doing. They're not allowed to think for themselves. They're not allowed to take a project on and develop it themselves in their own way. Everybody must do their part of the part of a project. Oh, this is the funniest part. You have to set out all the rules of how the project is put together so that everybody codes in the same way. No, you bloody well don't. But then, if somebody writes some code and they're off sick, how do we continue that code? It's easy. Sit down in that chair and continue the code. Just because they've done it in their style doesn't mean it's unreadable. Well, it shouldn't do, because if they can read it, another programmer should be able to read it. As long as they're writing in English. Prototype codes are done in English anyway. So you should just be able to follow the blooming prototype. Doesn't matter who's programming it. As long as everybody understands that the prototype code has to be in English. Whereas this prototype code that I'm doing here isn't in English. It's in Swift. And that's bad. You should not use Swift for prototyping. Is what I've got out of this. I'll be honest with you. I mean, I'm not going to pull any punches when it comes to stuff like that. It's because they like to engineer things. That's what managers do. They like to have good ideas to show they're the bosses and say, hey, look, this is productive, when all they're doing is pissing people around. That's what I found anyway. Actually, I walked out on my boss once upon a time. Came home and didn't go back to work for 4 days until they phoned me and said, "Are you coming into work?" And I said, "What's the point? My manager doesn't know what they're doing." So they found me a new job and said, "Now will you come to work?" I said, "Does the manager know what they're doing?" "Well, we think he does." "Okay, I'll come in then." That's the way I am. I will not put up with idiots. I would do my work because I like my work. I don't do my work because it pays any kind of money. I don't need money. Money doesn't mean anything to me. Which people find unusual, I suppose. Because that's not conventional. We got a vertex descriptor. Yes, we have. Yay. This, you see, Swift knows what you're doing as long as you're programming perfectly within its boundaries. As soon as I try and go outside of any of its boundaries and go into the manual, it's just unusable. It's like, what the hell is going on? Okay, we'll take a buffer allocator. See, it just puts it up for me. I suppose I must have one. There it is. Does it all for me. This is crazy crap. I like Swift. I think it's a really good programming language. I think they've done really well. But as soon as you want to try and prototype something, you just can't. It's like here I've used SIMD floats. Why have I used SIMD floats? Because the bloody thing wouldn't accept anything else. There you go. That's the answer. And that's even when I've done an alias. And I think I put it in maths. Yes, I did. If you have a look in matrix math here at the top, type alias, SIMD float 3. Would it just wouldn't let me do it. So, to that. To make it easier. Yay, we've got to meshes. Actually, we don't need that here. I can go up here, it's a var. You see, I put things in different places, I do things differently. But yeah, I mean, Seppi, I'll be honest with you. If you strip away from society and from industry all the stupidity and all of the crap that they place upon things and get things back to true basics, then productivity would go through the roof tomorrow. You'd have one guy sitting down there doing test-driven development. You'd have another person just doing development from his prototype. I would like to do test-driven development on here, but I can't see how it would work. Because every time I try and do something, it tells me you've got to do it this way. So there isn't any test-driven development, there's Swift or nothing. I suppose I'd learn how to do Swift properly. But I don't really want to program Swift properly. I want to do it improperly. I want to break out of this. I've already stopped using classes, because classes are just earth-shattering rubbish. Yeah, we've got an MTK mesh rather than an MDL mesh. There is an MDL mesh class, but we won't need to deal with it directly. To get our collection of MTK meshes, we use a convenience method provided by MTK mesh class, and it can throw an error. So the language is even checking itself. This is fantastic. I mean, have you ever seen me use a try catch in prototyping? No. Wonder why. And how would I know to do this do catch thingy? Because if I try to place this in without it, it will tell me to do it. Oh, this system is lovely. I mean, once I finish this UI, we're going over to Windows, I think. My original plan was to finish most of it off and put it up on the Apple Store, but I need development code. I don't need the finished product. But this is giving me finished product, which is a shame. Never mind. So MTK mesh. I'm not honestly too worried about what happens with this. New meshes. This is this init thing for new meshes. It comes off MTK mesh. How would I have known it? And in here we're going to have an asset, which it's just written in for me. There we go, there's our asset. Where are we getting our asset from? Right, I've got it there. It's off that let. Alright. Device is just, oh, it's an MTL device. I've got one, good. Now I've got to click on it, haven't I? Device. Yeah. There we go. And if we don't get it, we get a fatal error. Error. And that could not build mesh from model I. Oh. All right. So you can see how this is already looking like a final thing. Now, meshes doesn't seem to have decided that it's being used. Because it's in a do catch. So it doesn't know whether it's being used or not, so it marks it as variable has been written to. Pfft. Alrighty. So I've now got meshes, but that means nothing to me. Shaders file, I've made me shaders. Vertex shader. There's a vertex shader for you. Struct in out. Same kind of thing. Struct uniform. Same kind of things. Actually, I want to know how they do theirs. This is going to be an interesting article. Yeah, I know how to do that. Why do we need all of this? Not sure, but we might come back to that. Rasterization, fragment function, yeah, fragment function does that. Libraries, functions and render, load, build, pipeline, got you. Alright, we've done our library. We've done the vertex, we've done all of this. Pipeline. Pipeline descriptor, color attachment 0. Did I do that? Let's have a look. No, I changed mine to something different. So I'm having mine as something different. Pipeline descriptor, vertex descriptor equals vertex descriptor. That really does sound good. That's this line here. I've already described 0 and 1. We might have to add our own colours. MTL render pipeline state, yeah. Drawing, command queues, yeah, we've got a command queue. Command buffers and encoders. All I want to know is how to get that vertex buffer. Qt widget's not always good to debug. No, they're rubbish to debug. Yeah, they're hiding values. They are hiding the values in XML. There's an XML file, and it's a bugger to read and a bugger to alter. I know, because I've had to do it in the past. Very, very difficult. I found it initially. I found the Qt widgets very hard to work with, but nowadays I don't, because I've seen the errors, and I know where they are, and I know how to fix them. So that's just experience rather than anything else. Qt widgets though is useful for making a debug application. You'll see it on Amber Skies. I'll show you. Because I did some work for Amber Skies. Amber Skies. That's not me. That's me there. This one here. It's got 139 subscribers now. It's gone up. So this is my work as well. Qt stuff is in here. I've got playlists with it. There is one that I did with the widgets. I'm not sure which one. Probably this one here, learning C++ with Qt. I might use widgets, but possibly not. Oh yes, I do. You'll see how I set a screen up so that I can explore OpenGL. So it's an introduction to OpenGL at the same time. That's worth looking at. If you're looking at C++ with Qt. Shows how I set it all up to get the OpenGL inside the widgets and everything. And that's what you end up with. That's the final one. Yeah, that's interesting. So yeah, there's stuff on Amber Skies as well. It's got a damn sight more people than I have. I've got 3 subscribers on Fraser Sharp, and it's the same work that I'm doing, but this is more advanced, I suppose. Strange, isn't it? You do more advanced stuff and people don't want to look. Yeah. Let's have a look now. Draw uniforms, yeah. So I've done all of that. Let command buffer equal that. Let's have a look what I've done. Wait a minute, where's let command buffer? Oh, it'll be in the lets, won't it? Let command buffer equal command Q. Make command buffer, yeah. If let render past descriptor. Oh, I see. I think I just call it descriptor. Is view.current render past descriptor, and the drawable equals view dot current drawable. Yeah, so that's the same. Oh, sorry. This SIMD stuff is in common. It's up here. Position color, model matrix, view matrix, and projection matrix. So we've got that. I just call them model constants instead of uniforms, which they are in OpenGL. Alright, so command encoder. Most of this I think I've got right. Command encoder will be in rendering. It will come under encoder. Command encoder equals command buffer. Make render command encoder descriptor. Yep, render past descriptor, yep. Alright, when drawing, we will iterate over the meshes and the submeshes we created earlier from our model IO, drawing them as we go. The general structures look like this, though there are still some other pieces to fill in. So what you're saying is I need a different draw command. But I don't want that. Getting data into the vertex function. Okay. So let's see what they're doing. We'll go back to, this is going to be temporary code now, isn't it? So it's this vertex descriptor we've got. We're going to have to return that. That vertex descriptor, that goes in here. Damn it. I've got to hook all this together somehow. That's your offset and your index, yeah. But what about the vertex buffer? Right, I'm going to need the for loop. Do catch. Right, so that's the model data. Now we have to build the model. Right, so I think it's from there. Yes, it is. Don't know what we're going to do with the vertex descriptor yet. that. Cut. Model data. That's that bit. Now we need to transform that and build the model. We can now take this lot out. Because that's what we need to get somehow. I thought I'd just transfer something into there, but obviously I didn't. Okay, I'm going to have to take this lot out. For now. And this is what we need. This is what we're trying to fill in. This thing here. I want vertex, buffer, and index, buffer, and indices count. Are we going to get it? Oh, no. So for mesh in meshes, we shall do the following. For submesh in mesh.submesh. Submeshes, plural. Interesting. And we're going to do that. And now we've got to find something in there. Somehow. Getting data into the vertex function. Let's see how you do it. Buffer index. The buffer index corresponds to the property of the attributes. Yeah. Okay. What the hell's that? Oh, maths utilities. Yes. There we go. There's your maths utilities. If anybody wants to copy it off the internet, they look about right. Yeah, normal. Alright, the model matrix. I know how to do a model matrix. Yeah. Okay, view matrix. Zero, zero, -2. Why are you doing a -2 on that location, I wonder? Because you're putting this up in the air. Oh, that's a rotation. Increase the scale. Okay, fine. Model view matrix. Projection matrix. Yeah, we've got. Right, you can set up your uniforms, yeah. And that puts it on your encoder, yeah, I've got that already. Draw calls. Yeah. They're putting that in there. They're just returning the meshes. What the hell? That's too easy. Muppet, it looks too easy. There's something missing here. Oh, you cuties. Right, so this is going to be different. Right, what we need to do is we need to do two things. We need to go to Common Swift, rename that. That's our floor model. And in floor model, we better change it quick before it goes absolutely mental. There we go. There we go. And back here, in common, oh, I've just thought all the way through it. Wow, this works. Yay. We'll have another struct. And we'll call this game model. And what we are going to have in game model is whatever they put in here. Mesh. So we're going to have mesh. What the hell's a mesh? I have no idea what a mesh is. This is another problem I'm having with this this new game of playing Swift. It just let me... Right, it isn't mesh, it's meshes that we want. We want that. That's what we want. And I think that's all we want. Yes, it is. I hope it is. Something's bugging at the back of my mind. What is it? What's in here? Okay. Set render pipeline state, render pipeline, yeah. It won't have the color. Okay. We need the MTL. I think. Can't do it. That won't work. Unless we have separate buffers. I'm just going to see what it gives us, I suppose. Set vertex buffer. Well, no, I want the vertex buffer, don't I? No, I think there's a better way of doing this. Yeah, there is. Go back, go back, go back. No, I want those. I decided. I'm altering things to suit what I'm seeing on the left, and that's bad. So go back to that. Alright, so that stays working. Load model. We'll have to do something here. According to what I'm seeing, we don't need any of this. And we certainly don't want to do that, do we? Alright. What do we want? Vertex buffer. Equal mesh dot vertex buffers. Oh, it does have them. First. I'll do the command encoder at the other end, thanks. There's a vertex buffer ops. A what? Never mind. Command encoder does the vertex buffer here. I just put numbers in. Alright. But that should be resolved. Never mind. Okay. Let index underscore damn it, how do we do the count? Index buffer equal submesh dot index buffer. Oh. Why won't it populate them? interesting. Ah, thank you. We got rid of those two anyway. And the count is submesh index count. And we'll need another one, won't we? Bar count colon int 32, I suppose. I don't know. Let count equal submesh dot index count. There we go, and you just put that to there, to there. You should have it all. You've got return value. Can't convert to you prats. Never mind. If you can't convert, then God help us all. Hey, hiya, Kappa votes. I'm struggling through this thing. Oh God, I've got this cannot initialize thing again. What value type int? What type of value is it? Right, okay, I understand. Never mind. Pling you. Pling you. Pling you. Right, vertex, those have all gone away. Right. Never mutated. Fine. This is really silly, you see. It doesn't let you do anything. You can't do anything in this language. It's weird. I'm just not used to it. Okay, what's this? Initialization of immutable value vertex buffer was never used. Consider replacing it with a... It has been used though. It's here. Can you not see it? And down here you're now complaining what? It's used before initialized. FFS. I really don't understand this topsy-turvy thingy about initialization. What you're saying is you need this in a try-catch. I don't mind warnings, but that is impossible. It would have to be something by this stage. But we're letting that fall through. Alright, what I'm tempted to do here is to cut that. Oh, and all the warnings go away. No, we'll just keep it cut then. Stuff that. What I'm going to do is... Yikes. Take you out of here. Kappa votes, yeah. Hey, this is cool. So you've just got a message saying you've joined us. That's ace. Any questions you have about anything, just ask away. I'm just about to kill this by putting that in there. And I'm just going to return. What can I return? Return a value. Game. Model. Nil. Colon game model. Oh no. Just put in game model. There you go, before initialization. Can't do that. No, get away from me. Equal a game model. I don't understand how you're supposed to get out of this. I mean, it's just stupid. Just hacking around now, trying to see if we can get out of this stupidity. Alright. So now we cannot use this. We can't use these without it going through a return value. It's not dropping through anymore. It won't recognize them. Right, there's a better way of doing that. What the hell's that doing there? Alright, if we take you, cut you, place you to here. Get rid of all the U lot a minute. Actually, I shouldn't have done that. Let me just pop this back down here a minute. Making things up as I go. Fantastic. That's not an equal sign, that's a colon. Copy. To that. Am I allowed to do that? No. MTK mesh buffer. Has no member vertex buffer. Well, I'm not asking for that. That's not how it reads to me. What that reads to me is saying that the vertex buffer is equal to whatever you're going to give us. And it's reading it the other way around. Will it give me a type? Will it tell me anything about this? No. That's amazing. All right. What is going on? There's something a little weird going on here. Why can't I just dot it? Dot. There's nothing there. But it's a game model. And it has a var vertex buffer. It's here. Have I spelt something wrong? No, I haven't. There's nothing here. Oh, wait a minute. That's because we've got a let in front of it, isn't it? Right, got ya. The let goes there. Alright, well I want that as a constant. Hooray! I found the vertex buffer. if it'll put it in for me. Value of type MTK mesh buffer does not conform to an MTL buffer in assignment. Insert as. How many of these plings do you need? Alright, I'll agree with that. Fine. This is ridiculous. Game underscore model. You can fix that one, I don't care. Right. Game model. How are we doing? How are we doing now? Alright, what's this? What's the problem with this one? Has no member count. Yeah, I think you're right, actually. Oh. Oh. Oh, it's accepted it. Oh, wow. We actually got one right. That gets rid of that. And this is going to cause an error. Yeah, of course it will. I'll skip doing that, because it doesn't look good. Okay, now we have to alter this. So I've decided that that's possibly the best way of doing it, that. By assignment. Ooh, wow. It just went mental. What the hell happened? No. No. Oh, wrong one. That's not what you were saying here. Yeah, it does. If you go outside of there, you can't do without initialization. Right. Doesn't make sense. This is the biggest problem I'm having with this language. How the hell do you structure things together when they don't? Is that one of these brackety things? Thank you. And that will go down to that one's that one. All right. Is it one of them? No, it's got an unexpected initializer. Right, a let declaration can't be done like that at this stage, but what I've got a feeling is you can do this outside. Won't let me do that. Let declarations cannot be computed properties. Replete. Ah, right. Var, yeah, fix. Unresolved identifier mesh. Now, why would that be an unresolved identifier at this point? We've already done it here. Right. We're back to this, aren't we? Can assign a property game model is a get-only property. Pardon? Since when? It's a variable. Why have you locked it to a constant? Don't you just love it? Don't you just love it? If I was to put get set in there, what would happen? To start get definition. Interesting. Expected thingy to start set a definition. Are you taking the Are you going to let me access a vertex buffer now? Because if you do, that is stupid. Nope, you're not. So if it's a get-only property, how the hell are you supposed to set it? That's astounding. I've never known anything like this. Alright. Oh dear. What do you want semicolons for? It's just vertex buffer. It isn't, it's one statement. It's a chain query. Can I chain a query? No. You see, this is the problem with this damned language. This is impossible again. I noticed the bottom one it's not really bothered about. That's interesting. So I wonder if it is just equals. No. So how am I supposed to extract this buffer? Seriously. Seriously, seriously, seriously. You just can't do it. It's impossible. I wonder how far this goes. Alright, it's going way back. Okay. Okay. Those values die at that point there. Alright, pull you back out. Bring you back here. Alright. You see, that's correct. What I got in there, but the problem is how to get that information back out of there. Because this doesn't seem to act in the way that I was expecting. We've got a problem with our functionality in Swift. Doesn't surprise me, actually. Ah, dear. Now the cat's having a good time. Okay. So that code is correct up until we try and make the game model. And the problem that I've got with this, because I've got it here, but they're actually using it within. They're using the information within the braces, which is what I was looking at while I was trying to transfer that over. That information dies at that brace there. Vertex buffer is dead there. So I would need to do that. Vertex buffer. Oh. Interesting character it gave there. Type annotating missing in pattern. Wait, you shouldn't need a type. This is Swift. But no, you're going to need a type. And the type has to be the same as it is here in Matrix Common. Yeah, can we get rid of that rubbish? That was just funny. So those are all your type inferences. There's nothing I can do about that. But it's not seeing them. And it should come up now with the next one. But it hasn't. Give it time. Let's game model. Game model. Oh. Must have access as specified. Was written to. You're telling me that's wrong, aren't you? It doesn't know what an index buffer is. Oh my god. Same thing. Right, now what you're saying. Oh. Sorry. Right. All of them have been written to. Now if I do that, can I just... Variable game model was never initialized. Right, okay. Game model. Let's see what happens here. Dot vertex buffer equals vertex buffer. Struct game model must be completely initialized before a member is stored to. Right, so that means you have to do that, 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 and that. Cannot convert return expression of type MTL buffer to return type game model. No, you're lying. Okay. index buffer. Ooh, be careful there, Muppet, that's nasty. Indices count. Equals. What I'm thinking of doing here, just to stop any confusion, is putting that the other way around. Because it's confusing the hell out of me. Index buffer will become buffer index. This is the problem where variables don't work correctly. So that can go in there, and that can go in there. And now indices count can just be count. Now at this point, we've still got this load of rubbish up here, which says variable buffer vertex was written to but never read. So what's this doing? Are these commas? That's not correct. You don't use semicolons in this. Ooh, so how did we do it in here? Sunflower. It is with commas. Okay, now it's just bloody annoying. Why on earth can't I initialize that to that? Right, I'm going to try something. I'm going to take that 4. It's this bloody for loop. Alright. Is it possible to write? Is it possible to do something? I'm going to try something here instead. So, buffer vertex. Hello, buffer vertex. Can I at all put you equal to meshes dot? Is it going to just be mesh? Okay, first. No, so how's that for loop doing that? It creates mesh itself. So what is mesh? What is that type? This is annoying. Where's your type? MTK mesh. No, didn't mean that one. Meant that one. Initialization. Right. We've done the new meshes thing. So really what it means is submeshes. Vertex buffers. Is there a mesh vertex buffers? Constants. Here it's from conforms to. So the mesh has the vertex buffers. The vertex count and the vertex descriptor. I'm starting to think we don't need to do what we're doing. Okay. Have you got the vertex buffers then? No, it hasn't even got the vertex buffers here. Is it a submesh? How do you get the submesh then? Again, it's something it's auto-creating. But what is it? I'm just going to have to pass the mesh back. Oh, damn it. There's nothing else for it. MTK mesh. We'll call it meshes. Alright then. No, not doing that. No, don't do it that way. There you go. Do that. Scrap all that. Scrap all that. That's a complete waste of time, as it usually is. Oh, this is a good one now. Cannot convert return expression of type MTK mesh to return type MTK mesh. Okay. We'll have that then. Thank you. Now what's wrong with this part here? Oh yeah, that was me prattling around. Good. All happy? Everything looks happy. What's this here? Sand floor. We're doing game model. What are you doing? Alright. Game model. There we go. Sorted. You're okay now. You're semi-okay. Right, so if we don't do the sand floor thingy, we've got M, haven't we? Monster. Oh, this could be a mess. Anyway, let's try running and building and all that kind of good stuff. Alrighty, we have this picture. Very, very nice. But everything's disappeared, so never mind. Lovely. Hello, teapot. Never mind. Can we have this lot back, please? Thank you. Yeah. So in our renderer, we'll have to rewrite our renderer. Okay. Let's take that out. Alright, what should we call this? Let loaded model equal load model 3D device. No. Rendering device. There we go. It doesn't seem to be arguing with me. So what do we do with our command encoder? Set vertex buffer goes inside the for loop. Okay. So what we're going to do is we're going to try that. There. can't do you. Goodbye. And I can't do the draw call because we don't have the information. Okay. And we are going to try instead to do it this way. Alright, meshes. For each mesh in copy, paste. Okay, give it a command encoder to play with. And we'll just pretend everything's going to be happy, except there seems to be, oh god, yeah. Don't know why this is all the way over here, but I'll think about that later. Right, what happens if I do that? Build failed. Okay. Build failed. Okay. Yeah, that's what I was thinking. It's there. Tab. Tab. Try that one. Bugger, it worked. Why is it green? Well, bugger. That's awkward. I don't really care about the colour. For a second or two anyway. I mean, it's just going to be using whatever colour's been dumped in wherever in that buffer. Which is probably green because it'll be a normal or something. Alright, that's worked. Pardon? Do you know Herb Sutter? I think I know what you're talking about. You mean our Fedora guy? My mate. Yeah, I've been avoiding him, I must admit. He's got a lot to say, and it's all for profit. So, yeah. Not my ballpark, I think, really. Done quite a lot on the Kubernetes, hasn't he? Do I not have something from him at the moment I'm supposed to be reading? I keep ignoring his emails. Really shouldn't. Oh, thank God, no, I haven't. Okay. Yes, Mr. Sutter. Sutter. Alright, times are coming up over there, are they? Okay, I was a bit slow on doing that because I was engrossed in trying to get the letter M to come up on my screen. Amazingly, we did it. But that's with major problems. What that is doing is transferring the information off disk and then going straight to the renderer. We are not storing that mesh anywhere. Or did nobody notice that I did that? So that's pointless what we've done there. What we have to do is put something in between the renderer and the load model. And that's going to be in GUI. In our graphical user interface. Here. So when we want to render these things, I've got another bigger problem. We've got no for next loop. So we can unguard this lot. No, we can guard that lot, sorry. And at this point, we need a for next loop. Or a while. I think a while. For next loop means you have to predict how many things you want to do to render. Currently, we can only render one thing. Can everything after those top statements be wrapped up in a while loop? If it can, we can do this. Yeah, we would have to do a while loop while rendering, I suppose. So really what I'm thinking of is something along the lines of var rendering or render all equals true. And then while render all open the brackets there, go all the way down to the bottom, because you have to commit every single one individually. And currently we've got an endless while loop, and I think that's what it's trying to tell us. Yeah, I'll fix it in a minute. So at some point we have to put render all equals false. Currently, we've only got one thing. Let me see where I am. Where am I? Why have we got two here? Who's this second one? Who do you belong to, mister? A for loop. Okay. God, this is a mess. Render all equals false. If I put it there, it shouldn't get stuck, I think. Will never be executed. At least it told me. Right, that would go through normally. I haven't altered the program at all. What's this saying here? Burgy debug metal rogue but contents resource monster MTL. Oh right, you want the MTL file, don't you? Sorry, I realised that only halfway through, but I knew you needed it. Resource models. I do have one for you. It's here. Copy item. Finished. Ding. Right, we shouldn't have a problem with that now. God, that's small. Yeah, that's better. That's better. Yep, always read your output. If you don't say hello to you, there's something wrong. Right, so we now know that that is hitting 60 frames per second. What we also need to do now is include our other item. Right, what I'm going to do then is I'm going to take sunfloor. I'm going to take sunfloor out of this. I'm going to load everything instead. I want to see how slow I can get this. This is going to be bloody slow. Unless I can store everything. I'm going to go with the other one. Right. Let's start cleaning up. Sunfloor. You are the weakest link. Goodbye. Oh well, there it went. Never mind. Okay. Now we're cooking. Now it's starting to look like our original renderer. Alright, so that goes there. They don't really keep things tidy, do they? Oh, this is going to go awful. But anyway, here we go. Wallop. Hey, it worked. Oh my god. What the hell? There's another way of doing this, isn't there? What the hell have they done here? No, that's not what I asked for. Thank you. Where the hell is that bit? Alright, it's here. Got it. God, there's always one. No. That's correct. That's correct. Now we seem to be having a problem with our brackets. Do these all line up? That bracket should line up with another bracket. Here. Right. Please tell me that. No, it does expect another one. Where the hell is it? Right, that's it. I'm bringing my brackets out. So this. That goes with that one. I can't see the brackets. Oh, that's right. Yes, I found it. It's alright. Don't need to do that. God, you got to remember where all your brackets are or something in this game. Interesting. But yes, that's right. There is another bracket. It's there. So that's there. All of this is wrong. Great. The extreme person is now following. I'll tell you what, I'll do this off stream because tidying this up is just going to be a nightmare. The other bracket I was looking for, by the way, was right at the top. It comes under, yeah, the extension mark here. There, that line. That's the bracket that was missing. Right. We are now able to load objects. We are going to be able to now put stuff onto the screen. Multiply. That's interesting. Problem with it is this is not a batch renderer, and I said that last time with the C program, which we're taking this from. If we go back to our C program and have a look how we did it, yeah, it's okay. I don't want that. We don't need it anymore. I'm going to keep that. I'm going to have a look at that tonight. And so if we go back to... No, not you. Okay. Thank you. Who's you? That's downloads. No, don't want you. Archive. There we go. Let's go back into our previous stuff. Oh, for those of you who are visiting, Fraser Sharp on... In actual fact, if you just look up Sand Rogue on YouTube, you'll find the Sand Rogue videos, the full lot. With all the source code, of course, is on GitHub under Fraser Sharp. And it's Sand_Rogue you're looking for. I was thinking then, yeah, OpenGL. Let's have a look at our original renderings. And you'll see what I'm trying to get at. Open with, not Xcode, please. Just gets me confused. So this is the original, which I can't get hold of for some reason because I'm not inside the window. In the original, we were using OpenGL, and we were coming down with setting all the matrices, which we're about to do now for this one, by the way. And sky color, everything like that, all these uniforms were going in, which we're going to do for this one in a bit. Then we'd render the dungeon map first using the floor tile, which I've just deleted. Alright, so that would be a 4 next loop on the X and Z plane for each tile going down. At the end of map render, we would go through each of the current models that we had, which is our next stage in getting multiple things here up on the screen. Once we get the right models to put up on the screen, they'll be fine. And I'm going to colour them. Damn, that's going to be interesting. Blender, where are you? Oh, God knows. Hope we've got it somewhere. Then we'd render each one of those models using that for loop for however many there were. Current game state models to render, however many there were. We'll just go through all the models and render them. As simple as that. Well, that's exactly what we're going to do here, but we're going to use a while loop instead. And when we get to the end of the rendering, we'll just come out of the while loop. We can just set it to false. So what we're going to need is models to render. And that's going to come in on our graphical user interface here. So we are going to need, somewhere in this lot, models to render. And all it's going to be is an OBJ ID. Yeah. So I can put that at the bottom. That's a var, isn't it? Var models to render. We don't know how many there's going to be. It's just going to be a load of ints. 32, we don't care. And that's a colon. And that equals something or other. We don't know how many. So, do I know Jason Turner? Not personally, no. Why does that ring a bell? I've never met. Let's have a look. I've learned there's a plus thing. Jason. I don't think it was programming that he did. Alright, let's have a look at what he does. Oh, this thing. Yes, I've seen this. I have actually come across this. So look at its playlists. Yeah, there's not too much in this that I would use. But I've seen it. I've seen one of his presentations. I must admit, I think it's one of these I've seen. How and why to make your C++ cross-platform, because there's no other way of writing it. Here's the answer to that one. Performance. I think it was const expressions I looked up, because I wasn't too happy with the usage. But the rest of it, best practices, I don't like it. I'm not a big fan of this. That's a good one to look at. C++ Code Smells by Jason Turner. That I will confirm. Watch if you're doing C++. 100%. That is a video that you want to watch. I didn't watch his, I watched somebody else's version. 1 second. I'll go and find it for you. Oh, God, no, don't do that. We'll start running one of my videos. My old videos. Does it show it on? Yeah, here he is. Jamie King. This is the guy I want to give a shout out to if you want to start learning. This guy's... he messes around a bit and he makes it interesting. But he also is a teacher at MIT. Or was... No, he went to MIT. He's now... I think he might be teaching there now. I think that's what he wanted to do. But he's a teacher. Surgeon level software engineering is okay. But this is... Where is it? Doesn't come up on this one, does it? No. That says all playlists. No. Go to created playlists. I keep forgetting that. They all come up then. Game engine development is the one you want to be looking at, this one. And it'll go through absolutely everything you need to know about game engine development and stuff like that. I don't make game engines. I just write games when I want to. But that's where I got most of my knowledge for C++ and why things are like they are. But there you go. There you go. We might have learned something there. I don't know, but that's useful. That's useful information. Code smells are important. It's like knowing when to use GUI objects and not rendering. I know not to do what I've just done, which is this part here. That gets replaced with the while loop. So what we would do here is set up the while loop, and the while loop would be set up by get the list of models to render. Alright, then you go into render all. I think We might be able to make it a 4 next loop. We might be able to do it with a 4 next loop. So it may use a 4 next loop, a for loop, for number of models. And the list that we will receive back from there will hold whatever we needed here, which is the meshes. So it will be a list of these meshes. And I got a problem with that because I don't think that that's a pointer. Although if you just loaded meshes, it should be. I have no idea in this language if that's going to be a pointer or not. And if it isn't, the whole game is going to stop whilst it copies over all the meshes into the renderer. That's going to be ace. So there are problems ahead with this rendering thing. And we're going to have to solve quite a lot of this. And if you notice, I'm not using classes. The funny thing is, the first attempt, which was in the opening thing on Twitch, where I think I started it, yesterday. I think we threw away a complete an open scene graph thingy. I was starting to develop a scene graph, and then I just wondered to myself why the hell I was doing it, because I can't remember what the heck was where. So it was useless to me. We're going to need some models, that's for sure. Meow, 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 meow. Oh, what time is it? It's not meow, meow time. Silly cat. Silly cat. Deciding to meow too early. So what I think I'm going to do with this is grab a couple of models, let's say 2, and see if we can get them going. We've got monster in. Yeah, we'll use monster, but we need one other. And the one other I want to make myself. I want to make something akin to the gems game. Like a gem. Could even be semi-see-through, so the lighting can refract through it. Not that we've written the lighting or anything. I was going to put the matrix in. I want to do this model bit first. So where's Blender? Where's Blender indeed? Where's Blender when I need you? Right. Blender, where are you? Learn for Blender 3D, $4.99. Yeah, right. No, just Blender. It looks like we don't get Blender. Unless it's in a toolbox. No. No blender. Okay. Well, tough apple. We'll get it off here. .8, 3.5. Wow. Alrighty. Yeah, allow. What the hell, why not? Bing! Was that it? So where is it? What do I have to do with it? Alright. I guess I do that. Okay. What's this on here for? Eject? Ding. I guess. I have no idea how a Mac works. Oh, that's done something. It's gone bouncy bouncy. Yay. Yeah, go on, we'll open it. We'll take a plunge. Well, that looks familiar. Middle mouse button, is it? Yeah. Okay. There we go. Back cube. Delete. Object mode. Add. Text. Nah. Just wondering how the hell we're going to do this. I don't really want a plane, so yeah, I think we are going to be using a box. Oh god, that's awful. Oh well, never mind. I could use a grid. I'm trying to think of what's going to be the least number of vertices. A cube would work. Just flatten it. But then I'd have to extrude the middle. Not really up for that. How's about a grid? Used to be Alt-N, I think. Or just N. Yeah. Alt-N. No. I mean, how do I alter that? Add grid. Ah. It says subdivisions 10. Really? Oh, so it has. How's about a few less? Yeah. Okay. Scale. Transform, annotate. No, I want exactly what it's got there. But what we're going to do with it, I think we're just going to pull that middle bit up. How do I get to the faces? X rotation. Got to make sure it comes the right way. That's Y rotation, you twonk. Uh, 45. Yeah, that's the right way. So we'll have 90. Looking good. How big is that? Size. 0.5. Yeah. That'll do. It's about the size. Right. Object mode. I'm happy with that. We want to go to edit. And I want faces. And the only face I want to edit right now is you. How do I make it grow? Face. I think we'll have to go into vertex mode. Alright. Face. Edge. Edge. Right. This is interesting. I wonder if I can do this on a plane because it's got bevel. Might be able to. That's interesting. Extrude. Bridge. No, I'm not liking any of this. I think we might be able to just do it off a plane. Not sure. It's just 0.5. I know that. We know that the rotation is now 90. Like that. That's it. Can we bevel from there? No. Can we bevel the edge? Bevel edges. That's not overly useful, is it? No, that is definitely not useful. What have we got? Just that. Is that filled in, that plane, or what? Not much happening. Ah, here we are. I can't see it doing anything. Oh well. Never mind. Have to be careful with cubes. I remember the problems I used to have with them. This is a cube. Isn't it lovely? 0.5, please. Extend. What's this? Doesn't really matter. Oh yeah. Ah, that's worked. Good. Face. What happens if you just do extrude? Oh God. Right. Scale in the Y. Oh yeah. I'll go down to 0.1. That's it. We've got something going. Now really all I need to do is bevel the edges on that face. So select all, no, deselect all. I just want this one. That's better. That's what you were supposed to do. That. Yeah. God, it's a bit sensitive. And then it comes up with this. Segments 4? No, why not? Profile 0.5, yeah. Material, don't know, can't care. Yeah. Yeah. That's pretty much what I want. Alright, we'll go with that. Scale in the Z direction needs to be 0.5. Not sure. Not sure. It didn't extrude, did it? No, it didn't extrude. You. Face. Extrude. Oh my god, you have to do every single one individually. Okay. That's interesting. Control Z. I am so uncertain of this, aren't I? Great. Thanks for that. Edge. Bevel. Extrude edges. Yes, that might work. Maybe not. Interesting idea. I have no idea how to do this. Right, that'll do then. Just test it out with this, whatever. Cube. UV maps. Very pretty. Cube. What was that one? No. Object properties? Modifier, no. It's one of these two. No. Oh god, this has changed again. Particle. Physical properties. Oh wow. Object datas. New. Base color. Green, red, blue. Blue should be alright. Yeah, that looks alright. That's in edit mode, isn't it? Object mode. Bit more blue, I think. Alright. That's it. That's all I want to do. Alright, let's try it. New, open, blah, 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 blah. Export. Wavefront object. Wow, we're doing well. Desktop. Yeah. That's why I clicked on it. Weird. Metal Rogue. Metal Rogue. Resource. Models. I'm going to call this one what? Tile. Button. I'll make a different one later. Right, that'll do there. Selection only, please. Alright, geometry. Triangulate, export. Radio. I think I did it wrong. I have a feeling you just did it wrong. Oh no, it's there. Alrighty. I'll come back to you someday. Alright, models. Add files. You and you. Add. Ding. There we go. Alright, so if I change this now over to buttons, will it work? Button. What's going to happen? Oh, it worked. Oh, fantastic. We have a button. Yay. That wasn't hard. I don't like it being distorted like that anymore. I really don't. So what I'm going to do is we're going to have to do some matrix stuff, aren't we? Yeah. So let's go rendering. That was nice. That was nice and easy. I like that one. That part was nice and easy for once. I don't like it when it's hard and difficult. Notifications. Notifications may be included. Alerts, sounds and icon badges. Oh, sod it, allow it. We don't care that much. Actually, I've just realised something. I can load it from there, can't I? Just want to save. Save as. There's nowhere for models. 3D models. Pictures. Button. There you go. There you go, Blender. You've got somewhere to put things. You'll close quietly now. Right, so we've got a button. We need to do a little bits of sandboxing. What have we got here? That was rendering. Okay. decided on how we're going to render. Yeah, it is 1600 now. I'm going to have to stop at this point, aren't I? I'm going to leave this till tomorrow. The cat's meowing and it is after 4 now, so I do have to start paying attention to them. I think we're okay. We're okay. We've gone from our hello world to loading and stuff. Let's see how far I've actually gotten that today. So we've got rid of that one. We have actually got the base ECS, but it's just not being used. Alright, so let's just say yes, we've got that now. So we are going to do the matrix next, then we're into lighting and the picker. Fantastic. That'll do. Yeah. So, tomorrow is Sunday, is it? My God, yeah. For anybody who wants to or would like to follow this series, you are free to do so. I am on YouTube with this series, or soon will be. I don't exactly know how to get to myself yet, but it's at Fraser Sharp is my name. And I don't seem to exist, which is a bit annoying. So please find me. Try Sand. Rogue. Really annoying this. There you are, I'm there. It says it, Fraser Sharp. So just look up Sand Rogue for now. Do apologise for that. But yeah, I haven't got any views, likes or whatever. So it's not going to show as my name yet. So please, please, please come subscribe and do things. No, it's up to you. I never need anything me. So yeah, it's the 31 videos on Sand Rogue. And it's all in a simplified version of C. You can see here what we've got so far, which is the whole maps going out and everything. It looks quite good. And that was on day 7. Jesus. It goes all the way through to the monster AI, which we finally did quite nicely. So we've got all of that. All of this code we will be using in the finals. This is all, well, development code really. There's nothing special in there anyway. All simple stuff. And that shows you the diagram of how it all links together as well. Is on that one. But yeah, it's all working out. It's all working out. That version includes SDL2, CGLM, all gets loaded into that one. And it's all good fun. So I shall catch you tomorrow as we do our matrices and... Do I do lighting? We'll see how the matrices go, and then, yeah, probably will do lighting. And then we'll move that button somewhere and we'll start working on it. Somehow I've got to write letters onto that, you know. That's going to be fun. Okay. Take care, people. It's been a good Saturday. We've gone far. We've actually got a model loading. And I will catch you all tomorrow. Take care and have fun.